A Brief History of Space Exploration by Rochelle Young. The Space Race. Shortly after World War II, the United States and the Soviet Union each began their own missile programs. This launched what is known as the space race, which is where the history of space exploration begins. Respectfully, they both found success in their launches, the Soviet Union initially leading the race by sending the first artificial satellite into space and the first man. On October 4, 1957, the Soviets sent the first artificial satellite into orbit called Sputnik 1. Sputnik 1 weighed about 183 pounds and was approximately 23 inches in diameter. It featured two antennas in order to send data to Earth. Its mission was brief and burned up in our atmosphere on January 4, 1958. 4 years after the Soviets' successful launch of their satellite, on October 12, 1961, they sent the first man into outer space. Russian Lieutenant Yuri Gagarin became the first human to orbit Earth in Vostok 1. His flight lasted 108 minutes. On February 20, 1962, John Glenn's historic flight made him the first American to orbit Earth. Concluding the space race on July 20, 1969, the United States successfully launched its first manned ship to the moon, where Neil Armstrong became the first human to ever walk on the moon.
Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
After the moon. Although our trip to the moon had temporarily ended, NASA still continued to send humans into space. Over the next few decades, NASA led several projects in order to increase our understanding of the universe in which all humans reside. In 1973, NASA's Skylab program sent 3 human missions to stay aboard a small workshop that was constructed and orbiting Earth. The Skylab program was very successful in experimenting with long-duration human spaceflight. On April 12, 1981, NASA launched Columbia, the first space shuttle. Eventually, 4 more ships were added to the fleet: Atlantis, Challenger, Discovery, and Endeavour. Unfortunately, 2 of the ships were lost in explosions: Challenger in 1983 and Columbia in 2003. The program concluded in 2011 with having conducted 135 missions and sending over 300 astronauts into space. In 1984, the United States began work on what eventually would become the International Space Station. In 1993, several other countries, including Russia, joined the venture. On November 2, 2000, humans began to inhabit the space station. In recent years, we have sent several robotic spacecrafts to explore other planets in our solar system, such as Mars. Mars rovers have been able to provide humans with ample information about our neighboring planet and if it would have been possible to contain life. In addition, NASA has also sent several spacecrafts to do flybys past other planets in order to gain more knowledge on their atmosphere. We've sent spacecrafts to Venus, Mars, Jupiter, Saturn, and even Pluto. It's hard to picture life without space exploration, and honestly, why would you want to? Because of humans venturing into space and advancing technology, we have several amenities we otherwise wouldn't. Don't believe me? NASA actually created a list of all the items they have helped produce due to their advanced technology. These items include, but are not limited to, cell phones, firefighter gear, cameras, thermometers, freeze-dried food, UV-blocking sunglasses, invisible braces, MRI and CAT scans, memory foam, solar panels, ski boots, and water filters. There are several misconceptions about space, but a couple of them that are most common are stuff blows up in space, and a light year is a measurement of time. Many people believe that explosions in space can actually happen. This is likely because of movies that depict this sort of reaction. In fact, things don't explode in space at all. Space is a vacuum, meaning there's no air. Since there's no air, that means no oxygen. Without oxygen, there's no fire. And without fire, there's no explosions. Light years. Why wouldn't a light year mean a measurement of time? It has the word year in it, doesn't it? This is probably why so many people believe that a light year means some sort of amount of time, but actually it's a measurement of distance. 1 light year is about 5.9 times 10 to the 12th powered feet, which is a 59 followed by 11 zeros. That's a pretty big number. To put this in perspective, let's look at the sun. The sun is about 92,960,000 miles away from Earth, or 0.0000158 light years away. Isn't space enlightening?